Welcome to the ninth lab session of Computer Networks. In this lab, we will be studying the half-closed TCP connection. Previously, we studied the close function. In the close function call, firstly, we will closing the close client socket and then close server socket. Once we use the close socket, it means that we are completely terminating the connection, which means that if there are two hosts, for example, host A and host B, and host A is sending some data to the host B, and also the host B is sending data to the host A. And if you use the close function call, in that case, it means that you want to completely cut off the connection between the A and B, which means that either A or B cannot send or receive data from each other once you execute the close function. Owing to this property of the TCP, it is sometimes important that we close the connection from a single host, for example, the host A, and we still have the host B there, which means that the A host is not sending any data to the host B, but the host A can receive some data from the host B. So that is also possible using the half-closed TCP connection. TCP allows you to close each direction of the connection independently. A TCP connection is considered to be half closed when it is closed in one direction and still open in the other direction. In other words, this computer just want to receive the data at its input, but it is not going to send any data on its output, which means that it is receiving the data, but it is not sending any data. In short, the TCP half close provide the ability for one end of a connection to terminate its output while still receiving the data from the other end. And this is called half close. The host one will send, hey, I'm done sending data to you. And then it will send a finishing flag or finishing message to the other computer, which is host 2. Once the host 2 receive the finishing from the host A, it will send an acknowledgement, okay, I received your finishing, it's fine for me, but I can still send you the data. And once I am done with sending my data, then I will also send you a finish flag. So it will keep sending the data. The host 2 will keep sending data to the host 1. And once it is finished, once it is done with sending the data to, then in that case, it will send a finish flag again. Then when the host 1 also receive a finish flag from the host 1, in that case, both the computers are, both the host will just finish the TCP connection. And in this case, it's quite flexible. Although one host is not sending a data, but the other host keeps sending the data, and one host just inform the other host that I'm not sending you the data anymore, but you can still keep sending me the data. So socket has its input output stream, as I told you earlier, that a socket can have an input and then it can also have an output. The socket just inform that I'm not going to send you my output, but I can still receive the input from you. So if there is another computer, just we send this figure, it will say, for example, this is host A and this is host B. Host A will say that I'm not sending my output to you, but I can still receive the input from you. This will just inform this computer that I'm done with my sending and I'm not going to send any more data. But this will say, okay, I know that you don't want to send me, but I will keep sending you. And this computer will keep sending the data as long as it want. And once it is also done, then it will send a finishing. They will finish the connection. So here is the comparison between the typical TCP and the half-closed TCP. What happens in the typical TCP? Every TCP starts with the three-way handshaking technique. Firstly, it will send a synchronization, and then once the synchronizing packet is received from the ACTIO opener to the PCO opener, or from the client to the server, it will just accept the sync and it will acknowledge to the sync. And once the client receive the acknowledgement from the server, then it will send the acknowledgement again that okay, let's start it. So this three-way handshaking technique is very important for connection establishment or for establishing a connection between the client and the server. And then the data transmission starts from the client to the server and the server to the client, or in other words, if they are two hosts, so from one host 1 can send the data to host 2, and host 2 can receive data from the host 1, and then it also sends the data to the host 2. So two-way communication, half duplex or full duplex type of communication starts between the client and server. Now, this one, the client or the active opener wants to finish its transmission. It will send a finish flag towards the server, and the server will acknowledge that flag. And once the server receives the finish from the client side, it will also send the finish towards the client. And then when both are agreed with the finishing, for example, the server is agreed with the client side finishing, and the client is agreed with the server side finishing, then in that case it will also acknowledge the finishing and the connection is completely finished. So in typical TCP socket, we are done exchanging the data, let's close the connection, and then both are agreed and they say, okay, sure, let's close it. On the contrary, what happens in the half-closed TCP? When after the three-way handshaking that I just explained you here, the data transfer between the server and the clients is happening here, and once the one of the side wants to just close the data transmission, it will send a finishing flag towards the other side, which is the host 2, or it can be a server. And once it receives the finishing from here, it will just acknowledge with its data transmission, with the normal data transmission, and it will keep sending the data. And this one, since it has finished its transmission, but it can still acknowledge the data coming from the other side. So the data is coming from there, it's keep acknowledging, and then again the data is coming and it's keep acknowledging, and this thing is happening there. And once this one, the other side, if it wants to finish its own connection as well, it will also send a finish message towards this host, and then it will acknowledge that finishing, and finally the connection will be completely finished. So the difference between the two is when it sends a finishing, it will also send a finishing. So both sends the finishing and both acknowledging each other finishing. First, it acknowledged the finishing from the client side, and then also it sends the finishing from itself, since it knows that my partner wants to just finish the connection, so I have no reason to establish the connection anymore, and I should also finish the connection. And once this one receives the finishing from the server, then it is very happy, okay, you agreed with my finishing and let's finish it. And then it will also acknowledge, and once it is also acknowledged, then both are finished. But here the story is a bit different. This one side sends a finishing to the other side or the server. For example, the client sends a finishing towards the server, though it acknowledges the finishing from the client side, but it will still keep sending the data. It will say that, okay, I'm fine with not accepting the data from you, but I will still keep sending you the data until my data is finished. Or we can say that the data becomes somehow unidirectional, like it will sending the data like that, and meanwhile it will be receiving the acknowledgement also from there. And once this one is done with finishing the data, then it will also say, okay, I'm now also done with my finishing of data, so let's finish it. Once it receives the finishing from there, it will also acknowledge, and finally the connection is finished. Since I told you that previously we were using the close function, and close function was completely closing the connection between the two hosts, or which means that this will also send a finish message. Once it accept and acknowledge the finish from here, then it will also send a finish towards the um, previous host, and finally the connection is completely closed, or it is completely cut off as shown here. But if you want to just finish the connection from unidirection, just from one direction, and you keep sending from the other direction, in that case, we have a shutdown function call. And the shutdown function call, we shut down the socket from one side, and then it will also tells how to shut down that socket. So it terminates the output stream on a half closing party, which means that the former will just finish sending its data, but the other one, the later one, can still keep sending the data. This means that the calling process will not make any more output to the socket and will not only read incoming data from the host until the party also terminates the socket. The output is finished from the one side, but it can still receive the input from the other side. And it is still possible to completely close the socket if the process doesn't wish to wait for the peer party more. Okay, before going to explain you all about this code, let's go and do it practically. And once we finish with this code, then I'll come back and explain you. And that way you can easily understand this file server and file client code. So let's take a look at the two files like file server and file client and compile and run it. So as usual, I'll go to the cygn folder and there I'll make my own two files. So I'll just keep these two files and let me delete all the others. So let me delete everything from before and I want to write everything from the scratch. So these things can make me further confused. So I'll just delete it. And the same way I'll also delete everything from the file.server. Let me leave this part. So I'm going to delete all the unnecessary part and it's better to read it later on. And also let me delete this one. So I hope I'll not need them again. And also let me delete this one because this is not the operation that we had covered in the previous lab. So let me also delete it, and if it is also defined here, so then let me also delete it. So this is just I want why I'm deleting it and why not from the scratch. So in this from the scratch I have to write every header files and then I have to define this error handling and everything from the very scratch that I don't want. So let's keeps the thing that we need in the future and let's get rid of the things that we don't need. First of all, we need to declare some important variables as always. So first of all, let me define the file descriptor as integer. So one file descriptor I define for the server side and the other file descriptor I define for the client side. We will need to get the data or acquire the data from a file. So to have that, then we need to define a file pointer. So I will just define it like this, file and in the form of pointer, and let me call that file pointer. And then I may need to have some buffer, so I will just define a buffer. And since I haven't defined the buffer size, so I should also define it here. I hope 30 byte will be enough. And finally, let me declare a variable for the read count as well. And one more thing which is very important for, as always, the server address and the client address in the form of structure. So let me also do that. So I hope all these things you know from the beginning, so I don't have to explain it again. Since it's a server side, so again we will see the argc, and if it is like not equal to 2, so there should be the port address and also the initialization of the server. So if they are not equal to 2, then in that case we should have some error, so I'll keep this one. Now to open the file, you need to define a file pointer, which we have already done here. And the file pointer, use that file pointer, and then you have to use the fopen. So I believe that you have already done that in some C programming, and it's quite simple. So you have to specify the name of the file that you want to open, and it should be in the same directory. And if it is not in the same directory, then you have to specify the path for it. But since in this case I'll be using the same file underscore server.c file, I want to read this one file. So I'll just use this file. I think it is file server.c. Yeah, okay. And I want to read that in the form of byte. So for that one, I have to use the RB, and of course, it should be in the form of this and double quotes. So this is the file. This is the file pointer. So this is the file pointer which will open the file server.c, and it will read all the contents of it and byte by byte. Now let me open the server socket, which is this one. And so I think I don't have to again go through all these things. And now oops, I already had it here, so I think I should delete it. Now since I have this thing, so I will just copy it, and then I have the server address defined there, and I have everything here. So I think so far so good. We will keep everything like that, and then we will burn the server socket. Or in this here we don't have the server socket, so I'll just burn this one with the server address. And what is the server address? It is this one, and also the size of the server address. And if it is not there, then give me the error handling error that I have already defined there. Hit there. So the definition is here, but I'm just calling it. And if I don't have error, then I should go to the again I should just change it to the server SD, and I should at least accept 5, and I should keep listening to it. And again, if there is no listening from there, then I should have the handling error. Now we have defined the another variable, which is this one. So I'll just take it. I'll use it for the size of the client address. Now from the client side, I will just accept the any request coming from there. For that, we have already defined the client socket file descriptor. Now what I have to do, I I have created a file pointer, and then I'm reading this file. And when I'm reading this file, I have to read this file in the form of a buffer, and I have defined the buffer size, which is equal to 30, and the name of the buffer is BOF. So I'll keep reading this file. I'll going through this file, and I'll be reading almost 30 byte or one buffer window from here, and then I'll keep sending it towards the client side. So that is what I have to do in this part of the code. So I'll be doing it for infinity amount of time, which means I have to run the while loop for infinite amount of time unless it is false. And when it will be false, once we are finished with reading all this file. So once I'm done with reading this file, then I will just finish it. I will break it. This is the read count that we had defined here. Read the file from the file pointer, which is here, and from the file pointer we will be opening this file, and we will be keeping reading it byte by byte, and then for 30 byte with this size using this buffer by using the buffer size window. Once we read the file from there, we will simply send it towards the client side. But it will be better if we put a condition also. So the condition can be if my this read count is less than the buffer size, which means that we reach to the end of this fp file, which is the file server.c. So once we are done with the it means that we will have the 30 byte of window, and it will keep scrolling down like this. And once we reach this portion, and when we even read the last chunk of the code here, then in that case we should say that the condition is wrong, and we should just send the last chunk of the data towards the client and break it. We are reading the data from the file pointer, which is pointing towards the file server.c, and then there is a window which is the buffer window, and the buffering window will be keep reading that 30 byte of data from there. And once it is written, then we have accepted the client request, and we know what the client st is, or the file descriptor is. We will keep that as the address, and then we will keep sending the data of the buffer data that we just read towards the client side. And as long as we have not read the end of the data, we should keep doing it, and we should keep sending it there. And once we are done with that, then we should simply shut down the file from the server side. Instead of completely closing everything, we are going to just shut down it. So for that sake, we will be using the shutdown function that we just saw earlier in the slides. And shut down what? Shutdown means that shut down anything towards the client side, which means the output. So this is basically the output, because it is going to write at this socket, right? And what was the output? It was the address of the client. So the client address is shut down. And what is shut down there? Shut down the writing. So don't send anything on that output. However, keep reading anything coming from the client, so we can still accept the input from the client side. Output disabled, input is still there, and finally just print it out. We also have to close the file. So for that one, we have to use the fclose the fp. And finally, they close the client st and the server st, which means the client and server sockets. So that is it from the server side. I will simply save it, and we are done with this part. So now let's go towards the client side and write the code for the client side as well, and then compile it. Again, for the client side, I think I'll delete it up with this part, and I think the buffer size should be again 30, and I should have also this one. So here I'll firstly declare the buffer, and same as the server, I should also have the read count here. And also I need to declare the server address in the form of structure. Sorry, I should have not deleted this one, but it was deleted, so I had to rewrite it. Same as the server, we need a file pointer, and the file pointer will open the file, and then instead of uh, reading something that we did just from the server file server.c, so that was reading the file from this file server.c. In that case, it was rb. But here we have to open a file, and that file should keep storing anything that is coming from the server side. So we will just use again the fopen, the same as the client side, and then we should specify the name of the file that we want to read. So just I will say receive receive.dat. So I am going to receive this data from the server side, and then instead of reading it, I am going to write it into this file. So anything coming from the server side, it will be stored in the receive.dat. So this actually the client side will make another file which is receive.dat, and it will have almost the same content as the file underscore server.c, because the file underscore server.c was actually reading itself and keep sending it towards the server side, the client side, and the client side is actually receiving anything from there, and then it is just writing it into another file which we call it receive.dat. So after writing all the IP address and also the port address, everything there, then simply I will send a connection request towards the server. Now this is very important phrase here. So I'm going to send a connection request, and the connection request is the server address, and then anything coming from the server side, I am going to use the buffer that has the size of 30 that I have defined here. So anything coming from there and it is saved here in the buffer, I'm going to write it in the file, and it is almost reciprocal that what I had done there in the server side. So I will simply write it into a file that I have used, open it here, and the file descriptor is fp. So it will keep writing anything in the receive.data file, so it will create a receive.data file in the same directory. It will also put the receive file data there, and then once it read everything from there and it save it into the file which is a name receive.data, then it will just write a thank you message towards the server side. And to do that, it will also write something like write I think I should use this one till here, and after that all these things should happen, and then it should be closed. And finally I am also done with the client side, and again I'll just go through it. I'm reading anything coming from the server side, and I'm just writing it to this file, and once I'm done reading it, then once the whole file comes from the server and I'm finished with the reading it, and then keep writing it to the new file which is received.data. Finally, I will send a message like, thank you, I'm done reading with your data, and this should be received on the server side. And finally, I will close the socket as well. Let's go and compile these two files and see what happens. Let's say this is my server side and this one is my client side. Oops, client side. So for the server side, let me call it, I'm suppose that there is no server, right? So I will call it server. Finally, without error, I created the server, and then here I'll do the same thing, gcc client. Now I will just run the server at port number, let's say 2121. Okay, very good. And then I will also initiate the client and 127.0.0.1 and also the 2121. Oh, I'm sorry. I think I have done this wrong. So it's not the correct address. It's 127. So let me control C and also control C. I'm sorry for that one. So again, I will initiate the server and then I should do it like 127.0.0.1 and then 2121. Thank you. So I'm done with writing the file and received file data is here, and then I'll simply open with the notepad and it should contain the same file, almost the same file, not almost the same file, exactly the same file as we have the file client.c, because we were going to read something which was the this one. We were going to read something which was file server.c. So we were reading the whole file server.c, which is itself this one, and we were going to send it towards the client, and then the client was opening another file which was the received data, and then we were reading everything that was coming from the server and that received data file. So actually this should be exactly the same file as we have this one, so there shouldn't be any difference. Can you see any difference? Not at all. So except this is colorful and this is colorless. Why colorless? Because the extension is .data, it is not .c. If I make it .c, then it color will also become colorful like this. Your assignment was also like this, but there it was very simple file. You were reading from a file which was 2 or 3 lines of file, and it was not exactly this the file server.c that we did in this example. So I'll just briefly go through that example, and I'll also attempt your homework here, and I hope that will be enough to you to understand. Most of you have already attempted it, and if you have any doubt with solving it, so I'm going to do it for you now. So here is the your assignment files. So this was your server.c, and the server.c, there were various blanks that I had left for you, and you were supposed to fill all these blanks. And also in the client.c, you were supposed to fill up these blanks, and finally you had some data. So let's go and dive deep into the server.c and fill all the blanks that you were supposed to do. So if I start from the beginning, all these things have been declared. You have a file, and then you have a file which is named data.txt, and already that file data.txt is defined here. So the file pointer is um, containing this one. It is pointing towards the data.txt, and then it is reading it, and all the information is saved in the file pointer. um, and then you have the buffer of size 20, and finally you have a character with the buffer size defined. Here you have already defined this thing. So first of all, you need to put the port address. For that, I'll just copy and paste just to make the it more faster. So rather than writing it, let me copy and paste from the server.c. So I'll just go to there, and I'll just take the part from here and command C, and then I'll just put it here, and then I'll make all the necessary changes that are required. I'll just copy it here, and instead of this one I will paste it here, and then we are supposed to put the port number 1234. So I will just put 1234, and that is it. And then we have to bind it. So to bind it, we again have to go and take the binding operation from here. I will copy it, and then I will go to the server side, and then I'll simply paste it here. So again, we should have the server socket defined there, and the server socket, sorry, I didn't define it here. So again, I'll go and firstly I will define the server socket. So the server socket is this one. Simply copy it and paste it here. So the server socket is here. Now I have the server socket defined. So I will take the server socket, I will put it here, and then I have the server address. So the server address is this one, which I will copy it. I will just simply paste it here and then also here. So my binding process is done. Then I'm going to listen at that particular port. To do that, I have to go again there, and then I have to take the listening part. So I'll just simply copy this one. Sorry, I will go again, and I will just simply paste it here. So rather than server SD, I have to copy the server socket there, and instead of 5, I should just let me reduce it to 2 to make it more faster. And then since I have only 2 listening here, so I will simply start at n is equal to 0. So I have already declared the n there, and then n is less than equal to 2, which is same as this one, and then n plus plus. Now for the accepting everything, so I'll go again and I'll just copy the chunk of code which is related to the acceptance. So sorry, I'll do this one, and then what is the server socket, I will replace it with this one, and the client address is this one, and also the other one, the client address is already declared here. After accepting it, since I have already the file which is defined there on the top of the near the declaration, so the name is file.c. So I will simply use another function which is loads the function, right? So the rewind function, and then it's almost there, so I don't have to do anything there. And now I have the file length. Here, send the length of the file data. So it means firstly I have to send only this one towards the client side, and then the contents I think which is required here. So if I'm required to send the contents, then I have to send the buffer towards the client, and finally I have to terminate the output. So to do that, it's so easy. Let me just take the write command from the here from the previous file, and I'll go to this one, and I'll just simply paste the write command here. So instead of this one, since the uh, client socket is this one, so I'll take the client socket, and then I will send the this one. So and I send this one, and then let me keep it 1. Likewise, I will again copy it. I will copy it again, and then instead of this one I will paste it, and then again I'm going towards send it towards the client side, and instead of this one I'll now copy the buffer because I have to send the contents of the file, so I have to send it here, and then file length. So what is the file length? I will just copy it, and I will simply paste it here. And now I am done. All the required things are done. Now I have to terminate it. So I will simply copy the shutdown thing from there. I'll just copy it, and I will just paste it here. So this one. So the shutdown is there, and what to shut down? I need to send the output port, which is towards the client side, and shut down what? Shut down my writing. That is it. And also I want to receive, for example, the client response. So for that I need to define a character, right? So since I'm receiving some message from there, so I will make a character, and then I will just simply write it like client underscore response. So from the client response I will simply use the read. So I think I also have the read one, so just copy and paste it here. So instead of this one I will copy it, the client socket, I'll copy it, and then also I'll use the client response, and then size of the client response. That's it. And once I receive the client response from there, then I should simply print it out, right? So it's I think it's pretty much simple, just to use your printf command, and there it is, printf, and then I will say that the RECEIVED, let me say it is an integer, and then I will just, and anything coming from the client response. That is it. And then finally close the client side. Close, and what to close? I have to close the client socket. So Control C and the Control V here. And finally also close the file, and then again I will simply copy this one, and I hope you already know what we have to close again. So this should be the server socket, which was defined here. This one. And that's it. So save it. For the client side, I think it's more simpler than the server side. Again, I'll go to the server and I'll just copy the mm, socket thing from there. I'll just simply copy it and I will just simply paste it like this. Buffer should be the same, the buffer size should be the same, and then this and everything is given there, so you don't have to worry about anything like that. And then yeah, one more thing you have to address, this IP address is also required for the client, so that you have to firstly go to the previous file and you just copy the format for the IP address and this one, and then go to the client side and simply um, paste it here. And since you have to use the address, so firstly you have to change the server address. So I think I have this one. I will simply copy it, I will paste it, and then instead of this one, let me write inet, since I have to use this address. So inet underscore ADDR, and then in the this I will just simply copy, or you can just type it by yourself and then simply paste it. And then also you have to put the port address so that you can simply copy it from the previous one. So for the connection request, just go to the previous file and then copy the connection request from there and oops, and paste it here. So why I'm copying it, because I don't want to do everything from the scratch, and just like copying and paste can work much better. Here you will just put the client socket, which is this one, and then you have the server address, which is this one, and then again you have the server address, which is this one. So that's it. And now I have to receive something from the server side, so I will go to the server and I will simply uh, get the receive function from there. And what was the read function there? This one. So I'll simply copy it and I'll go again to the client side and I'll simply paste it. So here the client socket is fine, and then yeah, expected data length, so I will just simply replace this one with this one, and then also the size of expected data length, which is this one. So I think this is already written there, so I don't have to do anything. And then print out the received data. So to print the received data, firstly I have to initiate the buffer from 0. So I'll say buffer, and then I will inside the buffer I have received length, and that should be equal to this value, and after that just simply start printing it from that value, and then comma, and then you double FER. To send a byte value to the server, just let me define something like response is equal to 0, and then I should write it write the response towards the server side. Instead of writing, why don't I pick something from here? So I will just copy it, and I will just simply paste it here, and from here and here I will just simply write down the and response, and finally size of response. Then I have to close the client side. That's it. So I think we are good to go. I have the client side ready, and I also have the server side ready, and let's compile it and see what is happening there. So here is the server was reading that file, and the file contents are here. And if you see at the file contents, the server read from the file contents, which is, oops, sorry, okay. If you look at the server, the file contents, it is 0, 1, 2, 3, 4, 5, 6, and 7. So the server read all these file contents and send it towards the client, and the client then receives all those figures which are exactly the same in the file. So that is it for your assignment part. Now, if you look at this file, this file underscore server.c and file underscore client.c, I think everything is pretty much clear, and I don't have to explain it again. So that is it for today, and see you in the next lab. Thank you so much.